Hello and welcome back. So in our previous segment we learned how to measure the period of a planet going around its star. And so let's write that over here, and let's just say that we can now know the period, and that's going to be given by the Greek letter T, which is called tau. So now we know the period of this planet. The next thing that we're going to try to measure is going to be the orbital radius of this planet. Now, in order to do this, we're going to need to know the mass of the star that the planet is in orbit around. And now at this point, we don't know what that mass is. However, if you will stick around until the next unit, when we talk about stars, I'm going to show you how to measure the mass of a star. So we're going to do that in a future episode. So let's just assume that we can measure the mass of a star. So we can figure out then the distance from the star to its planet by using Kepler's third law. And Kepler's third law, so if you remember from, again, a previous episode, Kepler's original one was that the period squared was equal to the semi-major axis cubed. But then along comes Sir Isaac Newton, and then he modified the formula to account for the mass, and so his formula had the mass of the star plus the mass of the planet in the fraction there. And then later they figured out what the fundamental constant of gravity was, so that was big G. So we finally came up with a formula for Kepler's third law. Now take that formula and then rearrange it for the letter R, and then you get the one there, equation 5.9. And so that's going to be the radius, or the distance from the star to the planet, is going to be equal to the cubic root of this fundamental constant of nature of gravity, the gravitational constant, times the period squared, times the mass of the star, divided by 4 pi squared. Now you're saying, but that's the mass of the star, whereas this mass here should be the mass of the star plus the mass of the planet. Well, as an approximation, remember that, let's say it's Jupiter again. So Jupiter is going to be 1/10 the diameter of the sun. So that means that in terms of its volume, it's 1/1000th the volume of the sun, which means it's about 1/1000th the mass of the sun. So if you take the mass of the sun plus 1/1000th, well, that's pretty much the same as saying the mass of the sun. So we're making some approximations here and plugging it into that formula. And so now we can figure out the distance from the star to the planet if we know the mass of the star, which we'll be able to know that once we have done lesson number 16. And if we know the period, but we know the period from up here. So from the previous segment, we learned how to measure the period of a planet as it goes around its sun. So we can take all that information, plug it into that formula, and now we know the distance from the star to the planet that we're interested in. So let's go ahead and put that up here. So we'll say the distance R from the planet to its star. So now that's a new piece of information that we can measure. Okay, the next thing that we're going to do is we're going to measure now the mass of the planet. And so in order to do this, we're going to go back to the concept of center of mass, so that we can by knowing where the center of mass is, we can figure out the mass of that planet, again, if we know the mass of the star. So let's go back to our teeter-totter thing here. So here's the pivot point. That would be the center of mass. And then again, let's pretend that you've got an object over here that is going to be 2 times bigger than this object, a little thing out here. So this one's going to be 2 times the mass of this little box over here. So the question is, where should you put the box in order to keep it balanced? And it turns out you need to put it 2 times further away than you did this box over here. So we can now figure out what is the mass of the planet. So again, let's put that over here. Mass of the planet. And we'll put the letter M just to emphasize that. So in our next segment, we want to talk about how could you measure the radius of the planet. So I'll see you in just a moment.